All right, guys, we're back. We are still working on hammers. I'm running about 40% today. That's what I feel like. So I'm not moving very fast, but I'm getting some stuff done. And we have our billets all prepped. I've been in and out a little bit. And we're now punching the eye on the hammers. That's the next step here. So we've got 12 hammers total to punch eyes on. And let's see if I can get you where you can see what's going on. Got the hammer punch and the bottom jig there. So I'll try to get you guys to where you can see the actual hammer punching process here. That's pretty good, I guess. No, that's too close. You're not going to be able to see what's going on here. Bear with me. This is, well, we'll try that. All right, let me grab some hot steel and we'll punch an eye. So I've punched the eye on this hammer. Oops. And we'll just move that out of the way there. All right, we've got this hammer over here. And the slug, or whatever you want to call it, is still in there. Just barely hanging on. We just have to tap it out. And then we have a punched eye. So that's the first step there. Now it's super important how this is lined up. And you can adjust it a little bit, but it's much better if it's lined up from the beginning, because it's a pain in the neck to try to adjust it. So this hole right here, this eye, is going to get drifted out larger, and that's where the handle is going to go, of course. So let's grab another one. Okay, so I just wanted to show you guys the process for punching the hammer eye. So that's what it looks like. And I'll just bring you over here and show you what the tooling looks like. Again, you just got to punch here. This is H13 steel. So it's designed for hot work. It maintains dimensional integrity a lot better than just like your regular carbon steel like 4140 or something. So even at a red or dull red heat, it's not going to deform very much comparatively. Still have to keep it cool or you're going to be dressing your punch all the time. So I've got some punch lube, which is something that I make from beeswax and graphite powder, and it works pretty good. That's punch lube. It helps cool it a little bit, but after every hammer, I have to cool it down with water. Otherwise, I'm going to be getting too much deformation on the end of the punch, which makes it not come out of the. It makes it not come out of the hammer billet when you're punching, and that's a problem. So anyway, that's the process here. Here's our hammers we have to punch. We've got punched so far. These we have to do still, and I've got three in the forge right now. So that's the process here. Yes, Abel, I'm back. I told you I might be back. I just wanted to. Well, I was originally going to do a video on building the hammers. I've done videos on building hammers before, but these are for you guys, whoever wants to buy one. Had requests for them, so I was going to do a video and kind of figured maybe we'll just do a couple of live streams here throughout the process instead. And maybe that'll work. So now we just have to wait for the next set of billets to heat up. That's kind of what we're doing here. So far, I've only made blacksmithing hammers. That's correct. I was curious if we would get sort of a different set of people on this second live stream here. So I don't know. Abel, you were on the first one here earlier today. So I don't know who else we're gonna have on here or not, but the hammers we're forging are gonna look something like this. Been described as different many times. All right. Well, that's not always a bad thing now, is it? So Michael asked, what is the advantage to having a shorter, narrow head versus a longer head on the hammer? Well, it really just comes down to the type of ergonomics that you're after, and at least that's how I understand it. And I explained this in the first live stream here on the hammer build. But with a shorter distance on a hammer like this, the logic behind it is not having a difference in distance between the face of your hammer and your knuckles, so that when you're, full swing as you impact your workpiece, there's not an ergonomic tilt to your wrist, and it's better. I mean, a lot of people like it. I like it. If you were going to get a longer hammer face, you'd have to have a lower anvil. There's definitely ways to make different designs work, and obviously different people and different cultures even have different designs of hammers and configurations, and one isn't necessarily better than the other. They're just different, and you have to take into consideration different things. So this is pretty well centered up. It's kind of, if you haven't used one like this before, some people think they're harder to use. They're not. They're in a way they're more natural because you don't have a lot of weight out front, so they're pretty well balanced front to back. So as far as like tilting from side to side, they're a little more balanced. Abel, what else have you been smithing before, or something like that? Knives and hammers. Yeah, I do axes and hatchets as well. I think I have this is a kind of a Hudson Bay style small axe that I made a while ago. I make a pack axe. It's a little different than this. It's not a Hudson Bay style, but it's about the same size. So I forge these as well. What else have I forged beyond that? Years ago, I went to horseshoeing school, farrier school, and they taught us hot shoeing. They taught us how to forge horseshoes from scratch, from bar stock, and that was a good foundation for just general blacksmithing. And so I learned how to forge shoes and that kind of thing. So I've done that. I've done sort of ornamental, practical, like hooks and trammels and different things like that. I used to do quite a bit of that in the early days of Fire Creek Forge, which helped pay the bills. And I don't do that anymore. I don't have time to do that as well. But sorry for the sniffling. I have a cold, and so I guess I'm bringing you guys along on the real world stuff today. Kind of a slower day because I'm not feeling very good, but it's a good excuse to take some time to chat with you guys, I guess. So. Ben, I guess that's Ben at Beckers. Yes, I have an affinity for 52-100, and I would say that's my go-to steel. Yeah, I've talked a lot about it, and the reason I chose 52-100 steel as my flagship or main steel is the availability, the workability, and the affordability. There's one more. Anyway, the performance. I was trying to get them all to rhyme. Yeah, availability, performance, workability, and just the cost. So all those factors put together are why I chose 52-100. There's a lot of great steels out there, and they all require a little bit different approach, and but I think what really comes down to is picking a good steel and then learning how to use it really well, which takes time. You can't necessarily just jump into a steel and get the best out of it. So my recommendation is to pick a steel and stick with it for a while at least, and learn how to bring the best out of it, because 52100, for example, so to expand on those 4 qualifications, performance-wise, it's very good. It has the 1% carbon, which is higher than a lot of carbon steels, and it's got the 1.5% chromium, which really helps with grain control, grain growth control, and the hardenability a little bit too, or a fair amount. So properly forged, properly built knife and heat treated blade, you get a very tough steel with good combination of excellent abrasion resistance for edge retention within, and we're talking about carbon steels. Yeah, you can get into some of the high alloy steels, super steels, and they'll have better edge retention. They'll also be more difficult to sharpen, and they're also a lot more expensive. So I'm comparing 52100 steel to the carbon or high carbon steel family. So it's got very good edge retention and toughness, a combination of that. Workability, you can forge it. It's more difficult to forge than like 1080, but you can still forge it, and it also, there's no adverse effects to forging it. You can also do stock removal, which I do as well, either one. Availability, that's another big one. You can have a great steel, but if you can't get it, or if it's intermittently available, that's not great to depend on. And 52100, being the steel, the bearing steel that it is, has a lot of a wide application for bearings in industry, and so it's widely available. Even if it's in and it is in different stock dimensions that you can't always get other steels in. But let's say, for example, I've got a bunch of 3/4 round stock in 52100. Now that has to be forged, but you can forge that into a variety of different stock dimensions. The point is you can get it. And then finally, the affordability, again, because it is a common, widely used steel, kind of think of it, the more they make of it, the more affordable it can be. So if you're just doing a very small, like custom run of steel or something, that's going to be more expensive. So 52100 is widely available and made. A lot of it's made, so it's also affordable. So those are the factors. Hopefully that explains why. But I still work with some other steels. All right, I'm gonna go check on the billets real quick here, see where we're at on the next heat. Normally, I would be hand sanding or something in between, waiting for steel to heat up. But I guess I'm being lazy today. Sorry. We got to do this instead. So yeah, shoot some questions out there, guys. Well, we don't have as many people on this. I was actually surprised at how many people showed up on the first live stream today, and maybe most of them didn't want to come back to the second. I don't know. I was actually surprised, but still got some people on this one. By the way, if you don't have one of these mugs, or if you want one of these, or something like that, my wife runs a little Etsy shop where you can get this and a bunch of other cool blacksmithing and knife making like mugs and t-shirts, and it's all on sale right now. It's firecreekmercantile.etsy.com, and if you use promotion code FORGE, you can get an additional 10% off today. Only today though. Daytime job keeps getting in the way of Forge time. I know, right? Well, that's why you have to, I guess you can make it your daytime job. Alrighty, waiting on steel to heat up. Yeah, Steve. So there's different schools of thought. You know, you see some people holding their hammer out here with a long handle, and that's how they get more oomph behind it, I guess. These hammers are more designed to hold in here, so you have more balance. It's a heavier hammer, so you're not trying to hit as hard. So here's the thing, as I was forging, I didn't start out with a heavy hammer. I started out with like maybe a 2.5 pound hammer, maybe, I don't know. But for a long time, this hammer here has been my main forging hammer, and it's about 5.5 pounds. But I didn't start out with that. But what happened is, as you get used to using the hammer and you sort of reach the full potential of what that hammer can do for you with the mass that it has, and then you find if you want to move material faster, you have to start hitting it harder, which that's fine, but now you're trying to make the hammer do more work than is convenient, and so you're going to start tiring yourself out. So I found that it was actually advantageous to go to a heavier hammer. So that's what I do. So now I can let, just by virtue of dropping the hammer, and of course you put some muscle, some muscle behind it too, but you don't have to muscle it so much because it's got the mass to do that work for you, and so it becomes more efficient. And then you have to pull that hammer back up, but you're not trying to slam it down so hard, and so a heavier hammer allows you to do more work without having to do that by yourself. Does that make sense? So, where was I going with that? Yeah, so anyway, the point is that when you pull that hammer back up, a longer handle is leverage, and it's not advantageous to be holding it further out. It's better if you're holding it closer to the weight. So you kind of get both of those. You get the weight doing the work instead of your arm as much. And then instead of holding back here and having that weight work against your hand and arm as you're pulling it back up for the next swing, holding it in a more balanced position is better in that regard. Then you can come back for the next swing. And of course the rebound of your hammer also comes into play. You're not resetting from just a dead stop each time. So hopefully that answers the question. It's just, neither is the right way. You could become comfortable with either, I'm sure. This is generally what I prefer and what I use. So hopefully that answers the question there. Okay, checking for any more questions or comments. All right, our next 3 builds are ready to punch the ion, so I'll get you guys. Maybe I'll stick y'all back here behind the press so you can see from this angle. Maybe that'll work. I don't have a lot of room around the press, so it's not very advantageous for video. I should have a signal back there, I hope. Looks like we're still good. Let me know if we're still good with the signal there. All right, cool. Yeah, I'm gonna bring you back out here now. So yeah, punching hammers. Let me knock the plug out of this real quick here. Or the slug, whatever you want to call it. Where'd it go here? Sorry, my setup here is leaves something to be desired. So this is the slug. It's a little piece of steel that comes out, which is not very much. Everything else just gets moved to the side. This just little bit here just shears off. And that's the only material you'll actually lose out of the eye from punching it. And then we've got a nicely punched eye ready to be drifted on the next step. Try this here for the next one. Yeah, you're welcome, Stephen Johnson. Do I use temperature measurements? Are you talking about during forging or heat treating? Trying to get different perspectives here. Kind of hard to do. And forging. No, you just look at the steel. You know, also when you're using well, any forge is going to kind of have an upper range of temperature, and depending on how much fuel you're putting into that, you can kind of get it to where it runs at a pretty steady temperature. And so, you know, you can leave, which you don't want to do, I'm not saying that, but if you left a piece of steel in the forge, it would just run at whatever temperature the forge is up to and just stay there. And so if you've got to run it really high, which you would do for like forge welding, you know, that's not going to be appropriate for general forging. So you're going to run, like I run at about 5 psi right now on this forge for these hammers, and I can leave the billets in there if I wanted to for however long, and they would stay at a certain temperature, which is probably around, I don't know, 1800, 2000 degrees. But anyway, so it's just, you just kind of keep an eye. You just look at the steel, and as far as now what can happen is I could pull it out too soon, and it would be too cold to forge. It wouldn't have enough heat to where I can move this steel, and so yeah, you have to be cognizant of that. And again, that's just a matter of looking at it. You get used to the different colors and what the approximate temperature is, or at least the different colors and where you're at with the forging temperature. So I'm running these nice and hot. A bright yellow is where I want them at, because again, when you have a big block of steel like this, it doesn't move very easily unless you have it hot. And then also if you're doing a process like I'm punching both sides of the hammer, I need it to stay hot long enough to do that for both sides without having to put it back in the forge, which you could do it that way too, but it's just another step back into the forge. No, the steel is not going to melt in the forge, not in this forge anyway. There are forges you can run hot enough to start burning or melting the steel, but not this one. And probably not with most typical Venturi burner forges. All right, next billet. Drop the billet. Alright, that's how we do it. That's how it's done. So here's some questions about forging. Yeah, we still have flies here. It's kind of crazy to have flies in December, but they just don't die. Question about a Frosty T burner. I have my other little forge. I have a single burner forge that I built that has a Frosty T on it. And it's saying it doesn't get hot enough for forging. There's definitely something not right with, like, it definitely should get hot enough for forging, and in fact forge welding for that matter. Without seeing your setup, it's kind of hard to say. I don't, you know, if the burner itself is operating properly, which means it's the right size, everything's put together, it's running properly, the next thing you have to worry about is the forge itself and the dimensions of the forge. And so I'll show you, see if I can show you my setup here, what it looks like. Maybe that's the most helpful thing I can do here, is show you my Frosty T burner forge, because it works. And it's just sitting over here because I'm not using it right now. Okay, this is my Frosty T forge, Frosty T burner forge. There's the burner. I've added these little air control flaps, which you don't really have to do that. You can tune the forge or the burner with the length of your jet that you see right there inside. And then, so, you know, the length of your burner tube, that's important. If it's too short, it's not going to work. There's a formula for it. I don't know offhand, but this is a 3/4 pipe right here. And that's about, what, 10 inches long? Somewhere in there. There's literature on the Frosty T burners. So as long as your burner's good to go. And then, as you can see, for a single burner little forge there, this is pretty small. It's just, what, about 4 by 4.5 inside by 9 inches long, and that's it. And it's the insulating fire brick is what it's built out of. It works good. It'll get up to plenty hot for forging, and I can even forge weld in it if I really crank it up and let the billet soak. So it's not going to be as, you know, it's harder to get up to heat than like this thing with the 2 burners. But anyway, that's my Frosty T forge setup, and I added these doors, which you don't actually have to have for it to operate. But anyway, so I don't know what your forge looks like, but this is my Frosty T forge, or Frosty T burner forge, and it works just fine. And I still use it occasionally, particularly if I'm just working on like 1 or 2 blades at a time. Oops, I did it again. Accidentally exited out of the tab. The style of burner that's on the Whisper Daddy is a different, it's still a Venturi style burner. CJ asked, ever look into a ribbon burner style forge? I don't know if you're asking me that or Steve that. But I actually just ordered some parts to build a forced air forge. I'm not going to use a ribbon burner though. It's just going to be a single large burner. But I want something that I can forge weld stainless steel jacketing onto a high carbon blade steel, 5200 most specifically. But to forge weld stainless steel, you've got to have, it's kind of the upper limits of what a Venturi style burner forge can do. Not that you can't do it, but I have tried unsuccessfully, and I have also successfully forge welded a little bit of stainless steel foil to the inside of a canister project. So that tells me that it is potentially possible, but definitely, not within the comfortable operating temperature range for the Venturi style burner forges, at least any that I have used. And I've used a number of different ones. So that's why I want a forced air forge, and that's where you have a fan blowing air into a 2-inch pipe, and then you reduce it to a 1.5 inch or something like that, and then you're introducing your fuel, propane, most usually, in front of the fan or downwind of the fan, and that air and fuel has to mix. So you have to take that into consideration. You've got a 90-degree corner usually for that to create some turbulence for that fuel-air mixture to completely mix, or well, as much as possible before it enters the forge box, and that's where you've got a hot burning. It's kind of like your acetylene torch. You've got your bottle of acetylene or propane. You can I run mine on propane, and that'll burn, right? Just like your barbecue. Your barbecue is just burning propane, but then on your torch, then you turn on that oxygen side, and it makes things burns a lot hotter. So that's sort of the idea behind the forced air forge, and you get a lot hotter temperatures, and it's also more efficient for the fuel that you're burning. Now, obviously the Venturi style forge also uses air. It's pulling in air into that burner and mixing with the fuel, but it's limited. Like, you have to get more air to come in, you have to burn more fuel, okay? Because the difference in pressure between the front of the burner where the air and the fuel is coming in and the where it's coming into the forge, the difference in pressure is what sucks that down the tube. It's the Venturi effect, hence the name Venturi burner. And so to get more air to come in, you have to have more fuel and burning hotter and faster. And so I don't know. I mean, you kind of, it's sort of a diminishing return, I guess you could say, one way of looking at it. Whereas with a forced air, you're not relying on the energy of the burner itself to introduce more air, and so you can get higher temperatures with less fuel, or just higher temperatures period, and use less fuel if you want to. So anyway, that's why I'm going to be building a forced air forge. But you don't have to have one to forge. You can just get a regular, or build a regular little Venturi burner forge, and they work just fine for most of what you're going to do. CJ made a ribbon burner, and you've been happy with it. Yeah, that's good. There's some advantages to the ribbon burner, but for cost and overall, ease of build, and just for what I need, what I want it for, I don't need a ribbon burner. I just need the higher temperatures in a medium-sized forge box, really. All right, let me check on the billets here. right, guys. Well, I wanted to show you the process of punching the eye on these hammers. Obviously, there's a lot more to do on them. They have to be drifted out to a dimension, something like that. So we have an eye that a handle can go into. And these are pretty large eyes. I do that because the more material you have in the handle contacting the hammerhead, the more durable it is. So I'm going to continue on punching the rest of these. I think I'm going to call it quits on the live stream here, though. I appreciate you guys tuning in. Like I said, I just wanted to show you all the next stage of the process. And we'll be trying to get these hammers done hopefully this week. But if not this week, early next week. Like I said, I've been having multiple people request hammers. I haven't made any in a while. So just, again, if you're not aware, I'm doing a total of 12 hammers here. I've got 5 what'll be 3.5 pound hammers and 5 4.5 pound hammers. And then I've got 2 hammers that I'm going to do a specialty deal with a diagonal peen on them, just to see how that goes, and do a couple of those. So there should be a total of 12 hammers available within the next week or so, and those will be up on my website, firecreekforge.com. So you don't have to worry about a pre-order or anything like that this time. That's what I've done in the past, and guys have ordered specific weights, but this time I just chose a couple of weights that are pretty commonly requested and useful for a wide range of people, and you can pick which one you want, and it'll just be first come first serve as usual on the website there. And yeah, so we'll get these finished. If you're interested in well, if you want to know when they go up, go ahead and get on my email list on my website, front page of my website. I send out an email when I have new batches of stuff ready. So if you want to be like right there and not miss out on getting a hammer, that's probably the best way to do that. And I'll probably post it on YouTube here on the community section too when they're up. So anyway, I appreciate you guys watching. And let me check the comments one last time here. Stephen John said, yeah, this will go up on the channel there. It'll once it processes, the whole video will be up there. All right, thanks, Jeff. Yep, they'll be the hammers can't even talk. The hammers will be available in the next week or so. So appreciate you guys watching. Thanks for coming along. Have a good day. Have a good evening. Catch you on the next one.